Create a 10 minutes video for YouTube about Crimson Ring. Imagine a world so small it barely qualifies as a planet, yet so strange it's defying everything we thought we knew about the solar system. Meet Chiron, a rocky, icy wanderer orbiting between Saturn and Uranus. For decades it was just another Centaur object, a frozen relic drifting silently through space. But then something extraordinary happened. Astronomers found rings. Yes, rings, around an object barely 200 kilometers across. And that changed everything, because rings were supposed to be for giants, Saturn, Jupiter, Neptune, not for a minor planet the size of a small city. And that discovery, that faint shimmering band of dust and ice encircling Chiron, has forced scientists to rethink how planetary systems work, and even how life might spread across the solar system. But before we dive into Chiron's strange world, there's something else that shaped how we even got to this discovery. Something very human. You might remember the last major government shutdown that hit the United States, the longest in history. For 35 days, from late December 2018 into January 2019, large parts of NASA went dark. Telescopes were left unmanned, research was paused, and missions that depended on real-time monitoring suddenly had no one behind the screens. A shutdown, simply put, is when government operations partially stop because Congress hasn't approved funding in time. And when that happens, scientists, engineers, and researchers, even those watching the cosmos, are told to stand down. During that shutdown, space telescopes lost precious observation windows. Data collection from deep space missions like New Horizons and Cassini archives slowed down. The effects rippled across years of research, including projects tied to objects like Chiron. Because in space science, missing a week of data can mean missing a once-in-a-lifetime alignment. So when NASA and global observatories finally came back online, there was a renewed urgency, a determination to make up for lost time. And that's when something incredible came into focus. The faint light curves from Chiron, once thought to be just random dips in brightness, started to show patterns. Repeating symmetric patterns that hinted at something orbiting it. Rings. The first clues actually came from stellar occultations, when Chiron passed in front of distant stars. Each time, astronomers noticed the starlight dimmed not once, but multiple times, before and after the main event. That could only mean one thing: material surrounding Chiron. It wasn't the first time something like this had been seen. In 2014, a similar object named Chariklo, another Centaur, was confirmed to have rings, two distinct ones. But Chiron's case was more puzzling. Some observations showed clear ring-like structures, others didn't. Sometimes the rings seemed to vanish entirely. How could that be? Well, one theory suggests Chiron's rings might not be stable at all. They could be temporary, forming and dissipating as the object's orbit changes. You see, Chiron isn't fixed in a neat circular orbit. It's chaotic, constantly influenced by the gravity of Saturn and Uranus. Every few million years, its path shifts dramatically, and as it swings closer to the Sun, volatile ices on its surface vaporize, creating a temporary atmosphere, a coma, much like a comet's. Those outbursts might be feeding the rings, ejecting dust and ice that settle into orbit for a time before being blown away again. So Chiron might be a hybrid, part asteroid, part comet, part ringed mystery. But here's where it gets fascinating. If Chiron and Chariklo, two Centaurs, have rings, then ring formation might be far more common than we thought. It could mean that collisions, cryovolcanic activity, or even gravitational interactions are forming mini ring systems all across the outer solar system. That challenges our understanding of how planetary systems evolve. Because rings aren't just pretty, they're cradles of formation. In the early solar system, Rings of dust and gas were the birthplace of planets and moons. So if small bodies like Chiron can form rings now, it could mean that the processes that built worlds billions of years ago are still happening on a miniature scale. And that leads to an even deeper question. Could these rings be spreading organic material through the solar system? Some researchers have proposed that icy fragments from objects like Chiron, rich in carbon compounds, could be launched into interplanetary space during ring disruptions. Over millions of years, some of those fragments could eventually land on planets or moons, seeding them with the building blocks of life. In other words, Chiron might be a tiny, icy courier of chemistry, part of a cosmic delivery network that's been running since before Earth was even born. But not everyone agrees. Some scientists argue the data could be explained by jets, plumes of gas and dust shooting from Chiron's surface rather than rings. Others think the brightness changes are due to surface variations, like patches of reflective ice or dark carbon. The truth is, the evidence is still thin, because observing such a distant, dim object is incredibly hard. Even our best telescopes struggle to resolve it. And remember, the same shutdowns and funding delays that slow missions on Mars or lunar exploration also affect studies like this. Each time operations freeze, ground-based observation schedules collapse, telescope time is lost, and teams disperse. When Chiron's occultations happen, rare and brief, missing them can set research back by years. That's why scientists often call these shutdowns blind spots in progress. Not because they stop curiosity, but because they interrupt its flow. Still, humanity's persistence always finds a way through. In the years since the last major shutdown, new instruments like the James Webb Space Telescope and the Vera Rubin Observatory have changed the game. Webb's infrared sensitivity could detect faint dust signatures, helping confirm if Chiron's rings really exist, or if we've been misreading the light. Meanwhile, Rubin's survey power will track thousands of small bodies, revealing how common ring systems might be among Centaurs and Kuiper Belt objects. And here's where it gets poetic. The idea that a tiny forgotten world halfway between Saturn and Uranus might hold clues about how planets formed, how comets evolve, and maybe even how life spreads. All while our own human systems, shutdowns, funding debates, politics, threaten to pull the plug on the very curiosity that leads us there. So when we look at Chiron, we're not just studying a chunk of rock in space. We're watching the universe experiment, showing us that even the smallest worlds can carry the grandest mysteries. It reminds us that discovery doesn't always happen in the lab or the launch pad. Sometimes it flickers faintly in a telescope's lens during a cold night, while a star briefly disappears, and humanity holds its breath. Chiron's rings, if they exist, aren't just a scientific anomaly. They're a symbol of persistence, of wonder, and of how fragile our window into the universe really is. Because every time we shut down, we risk losing the next revelation, the next whisper from the cosmos. So the next time someone mentions Chiron, remember, it's not just a rock. It's a messenger from the borderlands of our solar system, hinting that creation is still unfolding in places we barely understand. And maybe, just maybe, it's telling us that the story of our universe is far from over. Because in space, even silence has structure. And sometimes that structure is a ring.